Welcome back, everyone, to Odyssey Codes. Today, we'll be covering object-oriented programming. So as you remember from the previous videos, we've covered a brief introduction of Java and its types, as well as the tools that we'll be using to accomplish our tasks. So today, I think it would be best if we deep dive into what exactly is object-oriented programming and why it's so important for us, especially when we're studying a language like Java and building things with that kind of language. So, object-oriented programming. If you remember from our previous session, we talked about how there's a difference between object-oriented programming and process-oriented programming, and then there's also functional programming as well, which when we cover a different language or even specific components of Java, we'll actually see functional programming in action in an object-oriented context. So, object-oriented programming is a way to organize a program or a piece of code around its data and create interfaces around that data. And we'll cover what an interface actually is. But you essentially want to think about it as data controlling access to the code. And for this, there are some principles that really bring this forth to light and bring this idea to light as well, that data controls the access to the code, and you're essentially controlling how you access that data within a class and how they interact. So object-oriented programming essentially is based off of the idea of abstraction. As human beings, when we go about our daily lives, most of the things that we interact with in the world, we abstract from their many parts. For example, when we look at a car, we don't necessarily think about all of the different components that encompass a car. We just think of a car as this one object that inside of it, if we wanted to go look in the details, we could decompose it into all of its parts. The main idea of abstraction, especially in the context of object-oriented programming, is that each object describes its own unique behavior and interaction with other objects. Just like a plate has its own unique behavior and interaction with other objects, so does a book, and so do all the other kind of objects in our world. Going back to the car example, a car itself would be the object, and yes, all the individual parts are also objects as well. But when we're thinking about a car as a whole, we only think about it with all of the pieces together as one object. The other really important thing about abstraction is hierarchical abstraction. So hierarchies, especially when we talk about inheritance and how some classes can inherit properties from other classes, and how important that concept will be, especially when we want to build very complex but also very abstract pieces of code. And we'll look at a couple examples there. The biggest idea, though, is that when we're talking about abstraction, we're talking about ideas over events. What that means is we first have to define what we want to say. What idea are we trying to convey? So when you have a car class, for example, what exactly are you trying to convey a car is comprised of? And we looked at, for example, Java strings, like the object string. What is that comprised of? What actions can you take on that object, and what actions can it take? So now we're going to look at three major principles of object-oriented programming. So these three principles underlie a lot of the discussions that we have, and I think it's important to understand these fundamentals because there are a lot of complex things that are built off of these fundamentals. So the first of these that we kind of touched on was encapsulation. So when we talk about encapsulation, we're essentially talking about a protective wrapper around the code that protects that code from outside interaction from other pieces of code. Essentially think about the car, and how, for example, the car's exterior, the car's body protects the engine and other internal components, including the driver, from the rain. The car encapsulates the individual. In Javaland and in a lot of other languages, this idea is conveyed by a class, where a class is what defines the structure and behavior that will be shared by those objects created from that class or an instance of that class. It's not to be confused with instance variables and member variables as well, but we'll get to those, especially when we look at examples. Most classes most internal elements of classes will be denoted with either public or private methods and variables that can either be accessed inside of the class or can also be accessed inside and outside of the class. Right now, we'll just be covering the public and private keywords because those are what we will be seeing a lot. But it is good to know that there is one other keyword called protected. And when we look at other more complex examples, we'll actually be able to see us use the protected keyword. So what exactly is a class and what does it look like? So simply put, a class is essentially comprised of private methods and private variables and public methods and public variables. And actually, I left out, so I'll put a public variable here. I left this out because when you are practicing clean code and writing clean code, you essentially never really want your variables inside of a class to be public. However, depending on what you're implementing and why you're implementing it, you may want to, but it is standard practice usually to make the variables private and allow public methods that are accessible outside of the that are accessible outside of the class per this arrow to access those private variables. So a class is at the bare minimum is comprised of these four components: the private method, the private variable, the public method, and the public variable. An example of this, if we remember, is when we looked at a book. We looked at a book. That book had an author, a number of pages. You even have a genre. And and at the back of a book is usually a description. All of these would be the member variables, and they would be private variables. In order to access these, you would, for example, have a method, a public method called getDescription. And the reason you do this is because you don't want anybody else, you don't want a magazine to come in and modify the contents of a book. You want it to just get the description, like the magazine will just describe the book, but you don't want it to change the description or change the genre or change the number of pages. And later on, there are things like immutable objects where you would return a list, for example, and you would make sure that that list is unmodifiable. So anybody who gets access to that piece of information is unable to change it. And this is essentially the core idea of encapsulation, where we want to detail the information that we want to describe that particular object, and then only allow objects that are similar, that are essentially the same type, to interact with that data. or only for that one instance to interact with its own data. When we talk about static variables, we'll talk about how there are some variables that are shared with every instance of a class, and why that's important to use. But for now, we'll just talk about private methods, private variables, public methods, and public variables. Okay. Now, after encapsulation, we have to talk about interfaces. Let's move this here and this here. So, an interface is essentially how one object gets, or inheritance. Inheritance. We'll talk about inheritance, interfaces, and all of that discussion will come later. But for inheritance, what we'll talk about is essentially going from the example that we had before, the process by which one object gets the properties of another object. So when we look at our example here, how a mammal and a reptile get properties from the animal class, and the dog essentially inherits everything from mammals and animal because it is down that tree. So a dog is both an animal and a mammal, but not all mammals are dogs and not all animals are dogs. It would be nice. But the way the hierarchy goes is that animal is at the highest level, and there are some animals that are mammals, and mammals inherit everything from the animal class, and dogs inherit all of the mammal traits. For example, hair and fur. So when we look at the formal definition, inheritance is essentially that process of how does one class inherit information or methods from another class. And what this allows us to do, it allows us to separate responsibility. We don't necessarily need mammals to know what all animals can do. We can define a class that allows us to do that and abstract that information from what a mammal does and from what a mammal is, because it allows us to create the separation between mammals and reptiles. Reptiles also don't necessarily need to know what all animals do. Only animals need to know. Only the animal class really needs to have a very broad definition of what all animals are. Mammals get a little bit more specific, but as I mentioned, not all mammals are dogs. When we get to that, to a dog, we're getting to be more specific in what a mammal and what a dog is. And if we put, for example, a particular kind of dog, like a golden, right, you'll see that not all dogs are golden retrievers, but a golden retriever is a dog, which inherits traits from being a dog, which inherits traits from being a mammal, which inherits traits from being an animal. Now, when we're looking at this hierarchy, it's important to notice the structure and how information flows down. Information does not flow up. So the animal here would be called the superclass of both mammal and reptile. Mammal is called the subclass of animal. Okay? Mammal is a superclass of dog because it comes above dog in the hierarchy. But dog is the subclass of mammal, and that chain of command essentially falls down the tree. This is the core idea of inheritance. You encapsulate as much information as possible, and then if you need more general information or you need to define a certain kind of behavior, you can inherit from another class, and you can share information that way. This is one of the simpler examples of how you can inherit. And I think, as we talked about before, in Java, everything is an object. So everything inherits from this object. So when we talk about strings, the object string, it inherits properties from the object. Or when we look at the integer class, capital I, you'll see that it inherits from an object. And so does everything else. And if we were to implement the animal class, you would see that it itself is an object and inherits everything inside of the base object class. But you can see animals are not strings and strings are not animals. Integers are not strings, and neither are they animals. So that is inheritance. The last really important principle is polymorphism. And what does polymorphism mean? Polymorphism essentially is many forms, and this is a principle that we will cover time and time again because it shows up in different ways. But it allows us to access objects of different types through the same interface. And the best way I could describe it is with an example. As you can see here, we have an interface speech. And what that interface speech allows us to do is speak. Now, going back to the first bullet point, access objects of different types through the same interface, and then each type can create its own implementation of this interface. So when we look at this example, a dog implements speech, which means that dogs can speak. And how do they speak? They bark. Okay? Here you'll see cats implement speech, and which means that they can also speak. But how do cats speak? Very different from how dogs speak. They meow. So you can see each type, so a dog and a cat can create their own implementations of this interface. Now, what's also important to note is that if I add, let's see, if I add another method to this, let's call it let's go here. Let's call it, let's change this actually. Let's call this communication. Right? Dog implements, dogs can communicate. Okay, and cats can also communicate. Okay. And when you communicate, you do speak, but then you also listen. So, dogs listen by wagging their tails. Okay. And cats listen by, well, who really knows, right? I hope this illustrates the basic idea of how, with an interface, you can have multiple methods, even variables, but we'll get to that. Multiple methods that you can define in that interface, and different classes can implement that interface. And this is just one form of polymorphism, and there are many complex ways that this principle is used, but the key idea for polymorphism is many forms. Okay, now that we've covered the three basic principles of object-oriented programming, let's see them in action. So going to the project that we've been working on, what we've done is we've defined what a reader is. So you can see here, a reader has a name, has the current book that they're reading, and they also have a favorite author. And you can see that all of these are private. They also have a variable that determines whether they are reading or not, the string that represents everything that they're thinking, and a private method that essentially defines what it is that they are thinking, and then these public variable or public methods that define when they start reading, when they stop reading, when they are reading, and whether they're reading. A public method that also gets their name, and a public method that defines how they communicate. And we'll get back to this communication later, because that communicate comes from our person interface. So similar to the dog and cat example, here we have a person interface where an author and a reader are both people. So they both implement person. So when we look at what an author is, an author implements person, which means that it has its own way of communication, saying, I have written a book. An author also has the variables that define their ID, their name, their location, as well as their favorite book. Now, to see all of this in action, you'll see here we've defined our reader, some reader, and an author. We won't even bother giving them a name. For now, all we need to understand is this. For a reader, we can access their name, but we cannot access their thoughts. Right? Because their thoughts are private. So you cannot access the variable and you cannot access the method because both of those are private. What you can access is whether the reader is reading or not. You can also access whether they start reading or not. And lastly, you can even access after you've changed whether they're reading or not. You can access that variable again, or that method which accesses the private variable to determine whether they're reading or not after they start reading. And here you'll see where polymorphism comes into play. They are both people, but they communicate differently. So people can take many forms. And you'll see here, the way the reader communicates will be different from how the author communicates. So the other thing that we needed to do is make sure here. Yeah. So now let's run this. Yeah. And what you'll see in our logs is that the application has started. We've defined our reader. And is the reader reading? No, they're not reading. After you tell them to start reading, they are reading. You can see it's changed to true. And then here you can see the two different ways that people can communicate. One way is by saying, I am reading. And the other way is by saying, I've written a book, because authors say they've written a book and readers say they are reading. And you can see here, we have to override the method in the interface because we're implementing that we're implementing that interface. There are also abstract classes where you can predefine what the method does. For example, abstract class here, static. Let's get the logger for our person. And you'll see that all people can communicate by talking. I'm talking. Okay. We do have to change our implementation because now this is an abstract class. So that also means that an abstract class can also define template code as well. So for example, void listen. Okay. So it can define both actual methods and their functionality if you want everything that implements this or extends this abstract class to use this without having to implement it. But then this one they do have to implement. So for now, let's remove this. Let's go here. Let's look at the reader. So this now changed to extends. And this now changed to extends. So that's really important. So you can implement interfaces and you extend classes. Okay. So you can implement interfaces, but you can extend classes. You can only extend classes. Okay. That's why this changed. So now the same principle applies. So if we run this now, you'll see, let the code compile. You'll see that they communicate the same way. But if we had decided not to implement the communication inside of our reader class, you see we don't get any errors anymore because all we're doing is extending this class and we already have an implementation for communicate. And that means that since we are inheriting the communicate from person, we can just call that method, right? That's what's called by default. So now when we run this, we'll see the difference. And there you go. You can see that when the reader communicates, they say, I am talking now, because they use the base implementation of the person abstract class. Then the author, which implements its own communicate, says, I have written a book, not I am talking. Okay. I hope this example has highlighted all of the differences between the three principles, and we've gotten to see them in action: encapsulation, inheritance, and polymorphism. All right. Till next time.